So today we are looking at 3.3 quadratic functions. The graph of a quadratic function is a parabola. So we looked at parabolas before. It's just a little U shape. So this is how it will look when the function is positive. The parabola opens up, and when there's a negative in front of your parent function, your parabola opens down. So there's things that we need to know about our parabola. The highest or lowest point is our vertex. So here I have the lowest point, my minimum. This is where my vertex is. So my vertex is my lowest point, which is -3, -2. So my vertex is the lowest or the highest, and this graph is the lowest point on the graph, and the vertex is -3, -2. And sometimes we want to know the axis of symmetry, which is, it's not a real line. It's like this imaginary line that we draw to split the parabola into two equal parts or two symmetrical parts. And when we divide it into half, we divide it through the x of our vertex. So when we draw the line going through, it goes through my x point. So the equation for my axis of symmetry is always x is equal to whatever your x coordinate is in your vertex. So your axis of symmetry and sometimes I write AOS is x is -3 because that's the point that it goes through. That's the vertical line that we draw to split it in half, and we split it through the x point. So we go through the x point of your vertex. And if we wanted to know our minimum value, we are familiar with that. We know that's always the y coordinate. So your minimum value is -2. So here, if you look, the x coordinate of the vertex is your equation for your axis of symmetry of the parabola. Now the same here, vertex here is your highest point. This graph is upside down, so that means that the equation of this parabola has a negative in front of it. And the vertex is 1, 3. And the vertex is the turning point. That's how we turn the parabola around and flip it, flip it like a chicken. So your vertex is 1, 3, and this is your highest point. So you're familiar with maximum and minimum. So this is the highest point. Your maximum will be 3. Remember, your maximum value and minimum value, hate with this line, is always your y coordinate. So it's the maximum value is 3. So it's nothing that's too new. Only thing that we are introducing is that point, that lowest point, that highest point. We're just introducing it as your vertex. And then your axis of symmetry is this imaginary line that we divide the parabola into 2 symmetrical parts. And at that point, that equation is whatever your x coordinate is. So you see here, this would be your axis of symmetry. X is equal to -1. So if you have any questions on just trying to figure out what the axis of symmetry is, locate in your vertex. And we already did maximum and minimum in our earlier section, so we should be up to date with that. Now I'm just going to throw you into the fire. So we have this graph, and we need to find the vertex, the axis of symmetry, and if there is a minimum or maximum value, and it's only going to be one. It's either going to be a minimum value or a maximum value. So it's just going to be either or. So you don't have two. So the vertex is your lowest point. If you can see it here, is 4, 1. So here is my vertex. And it's either the highest or lowest point. So here is the lowest point. So my vertex is 4, 1 is given. So that's nice. So we just look at the graph and pull the vertex right from it. And the axis of symmetry goes through your x, is always your x coordinate of your vertex. So x is 4. Therefore, my axis symmetry is x is equal to 4. That's the equation that I write. I have to write an equation. So just don't write axis of symmetry is 4. It has to be written as an equation. So therefore, you write x is equal to 4. Now your maximum value, we don't have one because the parabola opens upward. So if it opened upward, we have the lowest point. Our vertex is our lowest point. So we don't have a maximum value. So we do have a min, which is going to be what my y coordinate is of my vertex. So remember that's my y coordinate. So that's going to be 1. So you can write 1. You don't have to write y is equal to 1. It's not an equation, it's just what the number is. So we pull the vertex from the graph, which is 4, 1, and the axis of symmetry is x is equal to 4, which is 4 is the x coordinate of my vertex. The parabola opens upward, so that means that I don't have a maximum value. I only have a minimum. and that is that one. So any questions on finding the vertex axis of symmetry and whether we have a minimum or maximum value? Yes, if the parabola opens down, we will have a maximum value because that's my highest point. And if it opens up, that's your lowest point. Any other questions on looking at a graph, pulling the vertex from it, determining the axis of symmetry and your maximum value or your minimum value? So this is when, this is the fun part, just pulling it from the graph. But now, you know that we have to put in some work. We have to find the vertex and from an equation and pull all the information ourselves. So to find the vertex of a parabola, and when it's written in f of x is equal to ax squared plus bx plus c, we use a formula. It's here, but I'm just going to write it in people terms. So when we need to find the vertex of a parabola, we just take certain information from our equation, and we use this formula: x is equal to negative, well, x is equal to negative, and then b over 2a. I should write it like that. And this is how we find the x coordinate of the vertex. So we'll take this formula: x is equal to negative b over 2a, and we would use that to find the x coordinate of the vertex. And then once I know the x, I just plug that information back in the function to find y. So I will plug whatever x number I get back into the function, then I will have my y, and then I will have my vertex. So we calculate the x coordinate, and then we substitute that number back into the function to find y. So we have a little work to do and a formula to remember, but it's not that difficult because once we use the formula for x, we just plug that information back in to find y. Let's see that into action. And also while I'm here, I just want to see, you see here, if I have a function and there's a negative in front of my function, my parabola opens down. So if I have a negative in front of the function, it's going to open down. This one right here has positive, so it opens up. So we're going to see that in action anyway, so just wanted to make a note here, but we are going to see it in action. So here it is. For the function f of x is equal to 2x squared plus 10x plus 15, we need to find the vertex, the axis of symmetry, determine whether there's a maximum or minimum value, and find that value and graph the function. Now it's technical. Now it's serious. So the first thing we need to do, we know that this is the formula. And this is really the only part that we really need to know. X is equal to negative b over 2a to find the x coordinate. So we need to pull out an a and a b from our function. So remember that a is the coefficient of your x squared. B is the coefficient of your x. And we don't use C, but just to remember that C would be 15 if I were to be using the quadratic formula or something. But in this part, I only need an A and a B. So once I have my A and a B, I want to plug information into my vertex formula. So it looks like that I have negative 10 and then 2 times 2. So negative 10 over 4. And you want to reduce. We always reduce. So my x of my vertex is negative 5 over 2. Now I need to plug that back into the function to find the y. Okay, so here before we multiply 2 times the negative 5 half squared, we need to do the squaring part first. So negative 5 squared is 25. 2 squared is 4. Now I can reduce that to 25 over 2. And then the next one I can use a different color. 2 into 10 is 5. So that gives me a negative 25 plus 15. So 25 over 2, a negative 25 plus 15. I might combine that and have a negative 10. So 25 over 2 and the negative 10 is, the common denominator is 2. 25 minus 20, that gives me 5 halves. So my x is 5 over 2. I mean, my y is 5 over 2. So my vertex is negative 5 over 2, comma 5 halves. So the vertex, that's your vertex. And then your axis of symmetry is your x coordinate of the vertex. And here we know that the parabola is going to open upward because we don't have a negative in front of the function. It's positive. So we know it's going to open up. So that means that we have a minimum value. And that number is what my y is of the vertex. So the vertex tells me a lot of the things without even having the graph in front of me. I can determine my axis of symmetry, my vertex tells me I can determine my maximum and minimum value. I can determine my range if I needed to. The to determine whether it's going to open up or down, you look at the function. Because when you graph, that's just a point. Your vertex is just a point. So that doesn't determine whether it opens up or down. It's the beginning of your function here. I have a positive in front of the function, so it's going to be upward. If my function was written negative 2x squared plus 10x plus 15, that negative here tells me that it's going to open down. And your vertex could be negative numbers or positive numbers. That doesn't mean anything. It's only if there's a negative written in front of the function. So here I have the vertex that I just did, and see that it's the lowest point on the graph. Therefore, my minimum value is 5/2. And my axis of symmetry, when I draw the imaginary line through it, it's going through my x of my vertex, which is negative 5/2. So any questions on finding your vertex, your axis of symmetry, minimum or maximum? So we know it's only going to be either a minimum or maximum number. So in this one, we have a negative in front. So my parabola is going to open down. So it's going to open down. So that negative. So I need to find the vertex. So we start with the formula for the x. And once I find the x, the number back into the function and find y. I need an a. So my a is negative 5. Negative 5 is the coefficient of x squared. And my b is a positive 5. So I use a B, and then C we don't need, but C will be 2, just for practice. Okay, so now I need to plug this information in. So I have -5, -10. The negative came with the formula. A is negative, so that negative and negative is going to change it to a positive. And I reduce, so 5/10 is 1/2, 1/2. So my x is 1/2. And these fractions are probably freaking you out. Like, I need regular whole numbers, but it's better to do the fractions now than to do the easy ones. And then you go on my math lab and you can't do it. So it's better just to do the fractions now. So now I need to put 1/2 back into the function. So I want to do the parentheses first. So 1/2 squared is going to give me 1/4. And so that gives me -5/4. And then here, 5 times 1/2 is 5/2 plus 2. Then I just need to add these fractions together, so I get -5 plus 10 plus 8. And that is -5 plus 10, +5. 5 plus 8 is 13. So 13/4. So my vertex is 1/2 and 13/4. Now for my vertex, I can find my axis of symmetry. That would be my x coordinate of the vertex. So that is x is equal to 1/2. And my parabola is going to open downward, which means that when it's down, I have a maximum point. So that maximum point or number or value is what my y is in the vertex. So that is 13/4. And now I can graph the function because I have all the pieces that I need to graph. Now on my math lab, you probably would have to use the graphing tool that they give you. And we have these fractions, so you can change them to decimals and plot it. So you try to pinpoint based on the graph they give you and the tool that they use that you can try to pinpoint. So I know that it has a little scale, so you can probably just convert these fractions into decimals and then just plot it. So my axis of symmetry, my max. Any questions on finding the vertex, axis of symmetry? In this one, we're going to find the vertex again because we need all the practice that we can get, and maximum or minimum. And then this one's a little different. We want to find the range, and if the function is increasing, decreasing, or the intervals on which it's increasing, decreasing. So you can have increasing and decreasing on the parabola, but you just cannot have a maximum and minimum value. It has to be either one or the other. So we need to find the vertex, so we use our vertex formula. And we want to be careful with the signs. So A is a positive 1, B is negative 8, and C is going to be 5, but we don't need it. C is on vacation. He says, see you, I'm out. So now I just need to plug the information in. Negative. So a negative comes with the formula, and then B is negative, so changing that to a positive 8. And then in the denominator, 2 times 1 is 2. When I reduce, I get 4. So my x coordinate is 4. Now I plug 4 back in. Now everywhere I see x, I'm replacing it with 4. So 4 squared is 16. Negative 32 plus 5. 16 and negative 32 is negative 16. So negative 11. Now I can tell if my parabola opens up or down. So my x squared, the coefficient is a positive 1. So my parabola opens up. So that means that if it opens up, I have a minimum value. And without even looking at the graph, I know that minimum value is my y of my vertex. So the y of my vertex, or my y coordinate of my vertex, is negative 11. Therefore, my minimum value will be negative 11. I don't have a maximum one because my parabola opens upward, and that means that I have a minimum value. If it was going down on a Tuesday, I would have a max. And then the range is easy to find too. The range is your y coordinate. You use your coordinate to find your range. So if my parabola, let's see. So my vertex was 4, -11. And it opened upward and somewhere down here. Say this for. Now remember, the range is all of your y numbers that you use. So your range would be all these numbers going up here, all these numbers are your y's. So the lowest one would be a -11. So to positive, going up and up, positive infinity. So this is my range. So you would just take your y coordinate of your vertex, and that would be your range. If it's going up, then your number will start with your y coordinate, and then it goes to infinity. If it was down, your range will start with negative infinity to whatever your highest y is. So that would be your range. And we don't need domain. Domain is all real numbers anyway, so we just wanted to know the range. So any questions on finding the vertex, maximum value, minimum value, range, increasing and decreasing? We didn't do increasing and decreasing. So we know that increasing and decreasing, that's movement across your your x. I don't know why I always do that. That's movement across your x axis. So it's going to be your x coordinate of your vertex. So increasing, we know this is increasing. So we if we add 4, we would go from 4 to positive infinity. That would be my increasing. So remember, increasing and decreasing is your x coordinate of your vertex. And then decreasing is coming from your negative infinities, coming from here to 4. So that's increasing and decreasing. Any questions on that? So now we're going to look at a word problem. And guys like word problems. Just kidding. So we have this ball. We don't have anything to do. We trapped in the house, so we decided to throw this ball upward from a height of 5 feet with an initial velocity of 36 feet per second. And they give us the function, and they want me to find the time which the ball reaches the maximum height and they want me to find the maximum height. So I need to see how far I threw this ball and how long it took me to do it, because that information is important when we saving the world. So we need to use our vertex formula, because that tells me that gives me my information on my maximum height and the seconds that I need. Because if I'm standing somewhere throwing a ball up, it's me. I don't have that much here, and I'm the ball up, so it's going up. So I'm gonna have a maximum height up here, so it's going up there, and I just need to know how long it took me to throw it, because as you get older, you get arthritis and stuff, so I might throw slower. So now this is the formula that we are using. They give it to us here. So I just need an A, which is -16, and a B. And I just need a formula, my vertex formula. Just plug this information back in. So I plug it in, I get 36 over 32, and I can reduce that. So 4 into 36 is 9. 4 into 32 is 8. Now I'm going to change this to a decimal, because I need to know information in feet and seconds, so I want to change it. So when I divide this, I get 1.125. So this is the x is the time that it takes me to throw the ball. So I'm pretty good. It took me 1.125 seconds to throw this ball. So that gives me, x gives me how long it took me to do it. Now, to find how high it went, my maximum height, I plug in 1.125 back into the equation. So when I plug that back in, here I get -20.25. Here I get 40.5, and +5 is +5, and -20.25 plus 40.5 plus 5 is 25.25. So the ball reaches max height of 25.25 feet at 1.125 seconds after it has been thrown. So this is the two information. The two parts you need is 1.125, and the second part is 25.25, and that's all she wrote for that one. Any questions?